Have you attempted to install an HVAC thermostat or wire up an HVAC system and you saw what may be a confusing mass of wires, and it seems to be very cumbersome, very confusing, and perhaps even head scratching, and you wonder which wire goes where? What does one wire do? What does the other wire do? What does the other wire not do, etc. Once you understand the simplified version of the wiring, it becomes very simple. So perhaps taking the complex and simplifying it into layman's terms can help. So we take here a hypothetical, fictitious analogy here, and we say we're wiring up say an air handler and or a gas air handler could be the gas furnace, or perhaps a heat pump, etc. And once wiring this up, we start seeing these wires that look something along this line, and then they come out of the thermostat, the jacket or the sheathing here. And once they protrude out, we start wondering where these wires go and what the colors mean, etc. Well, when the high voltage reaches the air handler, and it goes through a transformer. So a transformer is, in this particular case, in many HVAC, and not all, but I'm not sure if at all or whatever, but the HVAC guys can elaborate. But mostly residential use, I think it's considered a step-down transformer. So if anybody knows, they can elaborate. But essentially, we're feeding, say, for instance, we're feeding high voltage, which would be 120 perhaps in a gas furnace, 240 or 208, 230 in a heat pump situation. And we're feeding it in on the primary side of the transformer. On the secondary side of the transformer, we're coming out with 24 volts. Now, this is where this wire here and this wire here becomes important. This is 24 volts. This is the low voltage side. So now, one caveat here, when dealing with low voltage, you think, well, that's not heavy voltage, so it's not a big deal, so I can find it. Many HVAC problems and shorts and head scratching situations actually arise on the low voltage side. So one may consider the low voltage, yes, it may be low voltage. However, finding a low voltage short, this takes a skilled professional to do this kind of work. And now, Joe homeowner can do it himself or herself, or whoever desires to do it. But keep in mind, without some skill behind you, you're thinking, well, low voltage, this is a piece of cake. Not always, but this is where this is where it can get tricky. Okay, but let's just say we come through, we feed the board or whatever, and then out to the board. So we have a red wire, and we're going towards the thermostat in the direction of the thermostat. So we have a red wire going in this direction, feeding to the thermostat. We have a blue wire coming, and it's connected to the thermostat. So the red wire feeds 24 volts going in this direction. Then it goes through the common. It should make a full circle. The way I kind of think of electricity, and now there's different 500 different schools of thought, but I kind of think of it as a circle. It just makes a full circle. And then when it hits the load side, then that's what actually the load side is, what, say, a motor we're desiring to use or whatever, or that sort of thing. We consider that the load side. The line side is feeding, the load side is what is activating. So in this particular case, this is low voltage. Just forget the small rant there, but we're feeding up to the thermostat with 24 volts. Okay, now we have several other wires. We have 1, 2, 3, 4, 5, 6 wires here in a 6-wire situation. One other tidbit of information. It's always better to have one or two extra wires in case one gets broken, and then the color coding may not be effective there, but you can run the system. You can use the other particular wire. But so we feed up to the thermostat. Now the thermostat's powered up. So the green is the fan, the yellow is the condenser, the white is the heat, etc. So if we were running the motor, the blower motor only, we would run the green, okay? And this would run some people call it the squirrel motor, some people call it the blower motor, whatever you want to call it. But and now when we're running heat and we're running the air conditioner, we still need the blower motor to push the air through the ducts. So we're feeding 24 volts here. We've got the thermostat. The thermostat is hot. The thermostat calls for cooling. So if we're in cooling mode, it hits the yellow wire, goes back through. Then the yellow wire is activated. So now this power jumps to this leg. So this leg goes back, feeds it, and goes through the sequence of operations. And this also should power up the blower motor here too. But hypothetically, if we're in heat mode, we go here and we jump her over here. So now the red wire's hot and the white wire's hot and the green wire's hot. Goes back to the computer board through the air handler, and the sequence of operation happens. So, but keep in mind, when we're powering this 24 volts, it should come up this way to the thermostat, go through the common. The common should be commonly connected. So these are the two important wires that are your low voltage. Your 24 volts is your red is your power wire, and your blue is, generally speaking, your common wire. Not always now. It's not universal, but it's pretty standard in the industry. So these other wires are going to control something: heat, cooling, fan, etc. So what we're going to do when the thermostat is going to be, hypothetically, a fictitious analogy here would be the brains of the situation. So when the thermostat calls for it, it would jump her over here. If we wanted fan, turn the fan on. This power here would go here and go back and activate. Okay, if we were wanting the cooling system on, this power would jump her over here. We have power here, we have power here, it goes back. And keep in mind, when the power is here, the power's on this wire and this wire, because we do need a blower to get the air through the ducts. If we're doing heat, the power jumps from here to the white and the green, and then it makes a full circle and the common is connected, and that's how it's done. To reiterate, we have the red wire is the power wire, the blue wire is the common wire. These are your two important wires. Keep in mind, we go back upstream, and we go back upstream in the air handler, we have a transformer. We're stepping this down. Say if it were a gas furnace, we're stepping it down from 120, hypothetically, to 24 volts. We come back. This is where we get our 24 volts. So these are our two important wires here. Now, these wires here are important too, but if we don't have any power here, we're in trouble here. So this power here, when we want, again, say if we wanted to do the fan, boom, we hit the thermostat and it energizes this wire here, goes back and cuts it on. So the red is the power wire going up to the thermostat. The common is the commonality between these, and these wires here are to energize whatever particular unit you need to energize. Thank you for watching, and have a wonderful day.